जी, अस्सलाम वालेकुम. Can you hear me?
Yes, yes.
Okay. Because I lost your voice, Shahud, while you were presenting myself, so I lost your voice. So I
Huh?
can start?
Okay, sorry. Yes, you can start. We are waiting for you.
Okay. Bismillahirrahmanirrahim. Assalamu alaikum everyone. I hope आप सब खैरियत से होंगे. तो let's start with the topic. You can see my screen.
Yes, it's okay.
Okay. So, yeah. Now you can see my screen, right?
Yes,
Before going to the topic, so I will take the opportunity to present SETI. SETI is a young research and development center located in north of France, not so far from Paris. So we help textile companies and material manufacturer to develop their products for textile application in different fields, for example, in textile, technical textile, professional equipment, sports, and luxury. So we have world-class network around the globe. That means that we are closely working with the world leaders that are working specifically more on textile recycling, fiber development, and the textile product development. And also we are a part of different associations, SIF, EDANA, and IVGT. We mainly work on fiber development and the Novo One textiles. And in addition to that, we are also a part of different companies who who do the project management with us. So our main expertise are on recycling, technology transfers, alternative materials, smart textile, and digitalization. So when I said recycling, so in SETI is currently doing two types of textile recycling: mechanical textile recycling and thermomechanical textile recycling. And also we help textile or different companies to develop their product at pilot scale, and then we help SETI help them to transfer from pilot scale to the industrial production. And also we help different material manufacturers to develop alternative material, for example, from fossil based material to bio-based materials, and also development of smart textile and digitalization. So, like I said, SETI is currently doing textile recycling. SETI started textile recycling since 2019. We started with the mechanical recycling, and now we are also doing a thermomechanical recycling. So, um, we got the SETI also got the funding from European Union. So that also shows that the Europe is like investing on the textile recycling to promote the post-consumer textile recycling or post-production, industrial production textile recycling solution. So we got the funding, 8 million euros to invest on the textile recycling topic. And also we also got the funding from BPI France that to promote the textile to textile recycling solution. One of the example of is we are part of SCAT project. The main objective of this project is to develop a textile to textiles recycling solution that involves all the process. I will present in the coming slide that involves mechanical recycling, thermal recycling, and the chemical recycling. So we are closely working with different partners that involves different companies and universities and organizations that works in different topics and specialization fields. So SETI is working on the mainly mechanical recycling, thermomechanical recycling, and from that recycled materials, we are developing the fibers to make the textile for end-use applications. So one may think why we need to recycle the textile. Well, the answer is like with there's a fast growing fashion trends that is rapidly increasing day by day, and it's like polluting our environment and impact, and also we have more reliability on fossil fuels, so that globally that is impacting the global warming effect. So we have to find the solutions to recycle the material. For the moment, only small portion of these textiles are being recycled. So when we linked to the textile to the circular economy is we have to find the solution to so that we can recycle this material and to put to make the to recycle and make the textile again for to use them again, and also we can minimize the environmental impact and also less reliability on the fossil fuels. So how we can start, how we can help the circular economy. So we have to develop the collection systems, and we have to collaborate each other to develop a method so we can develop a circular economy system that can help and promote the textile to textile cycling solution. So when it comes to textile industry, so normally from the textiles industry, the main products we have to recycle is post-consumer or post-industrial waste, and also we have less natural resources to use day by day because of the global warming effect. So for textile recycling, that involves different steps. For example, we have to collect, we have to sort it, and then we have to prepare a feedstock from for to recycle further. That requires a lot of investment and also technology aspects. For the moment, it's like the textile recycling is still in research and development phase, and we are not the world is not doing the textile recycling and industrial phase. So at the moment there is only the research and development on the textile recycling. So the mainly the governments, like I give the example of European unions, the governments of each countries, they are closely working to invest more and more on this topic to find the solution for textile recycling. So mainly in textile recycling, there are main three processes: mechanical, thermal, and chemical recycling. And in each of the process, there are further different steps. In mechanical recycling, for example, is grinding, frying, and there is also further step with purification and without purification. And then we have a thermal recycling, thermochemical, that involves thermomechanical and thermochemical. And then the third one, we have a chemical recycling that involves the recycling of polymers or recycling of monomers. But today we mainly focus on the what is the thermomechanical recycling of the textile. When it comes to the definition, so basically in thermomechanical recycling process, so we use the synthetic material, more specifically the material should be thermoplastic. So then we take this thermoplastic material or synthetic material and put in the extruder, and then we melt it by a high temperature and pressure, and then we transfer it into granules. And that's this granules, we can use it to develop further the fibers or other products from that granules. So this is the major definition of thermomechanical. There we use a synthetic material, specifically thermoplastic material, and then we, through high pressure and temperature, we transfer this material into granules, and from that granules you can develop a fiber and then afterwards a textile. So how we can link thermomechanical recycling process to our closed loop textile to textile recycling. Uh, uh, so for example, after using post consumer or post industrial waste, you have to collect the textile waste, and then you have to sort it, the textile based on their material and the type of color, and then you have to prepare the feedstock in order to feed the thermomechanical process. So these two steps is very challenging for the moment. I will explain in the coming slide. For example, the textile collection requires a lot of investment and a lot of time to collect. So, and then we have to sort it. If the material is not well sorted, based on their color and material, that may cause the processing problems during the thermomechanical process. And at this step, thermomechanical step, then you can make the when you have the granules out of this process, then you can make a yarn out of this based on the properties that you wanted to target. For example, you can produce partial oriented yarn and fully draw yarn, and then from that yarn you can make the apparel or the fabric based on their application. So there are different challenges after the recycling of the textiles. I mean, here at this step, I will describe in the coming slide that you lose material property after recycling. So there is also the big challenge how we can improve the material properties to put that material or reuse that material in a closed loop textile to textile recycling. And then we firstly start from the, like I said, the first step is a fiber collection, and then you have to sort the materials. So there are at the moment, so the textile sorting is mainly done by a manual sorting process that takes a lot of time and a lot of investment, like I said. But there are different companies around the world that are mainly working on the textile sorting process, and the main principle of the main technology of their sorting is they use near infrared spectroscopy, optical sensors, robotics, and intelligent tools to separate the materials based on their color, type, and the if there is a metal residue. Um, and depending on that, they separate the textile, and then we can process afterwards. So Volvon is one of the known sorting company based in Europe that sort the textiles based on their color and the material. The main, I think, the speed of this plant is 10 millisecond. Yeah. So their technology is based on the infrared, near infrared spectroscopy. So based on their color, material, so they separate the materials. So this is, like I said, this is very important step, sorting. If the sorting is not well done at this point, so that can cause the problems during processing in thermomechanical step. So how it works, the thermomechanical recycling process. So when the material is well sorted, so for example, I give you example of that we trials that we have done in SETI. One of the customer, they give us the curtains, the window curtains, and then first we have to shred it and to put in a size that is more suitable for this machine for thermomechanical recycling process. So first we shred it and make a suitable size to feed in the thermomechanical process. So we feed it, and then we put in the densifying unit. There you densify it. That means you further shred it and make microfibers out of this through a mechanical friction. When you have that kind of material out of that, then this densification, after this densification step, this material goes in the extruder, like if you have the experience of the polymer extrusion. So you feed that feedstock in the extruder, and then you apply high temperature and pressure, and then you get a polymer melt stream out of that. And then here you filter and you remove all the contaminants, because if this is a post-consumer textile waste, so that requires high filtration to remove all the impurities that includes in the textile. So if the filtration is not well done, that may cause the processing problem during the fiber development afterwards. So the filtration must be very well done here. So because these days, like if the contamination is too high, so we cannot process the materials. but it goes well. So at the end, after filtration, you have a pellets collection system, and then this melt stream is transferred into the pellets. This is a machine from Arima that is we have it in SETI, a complete thermomechanical recycling process. So I make a video just to show you how the thermomechanical process. Please confirm if you can see that video. Yeah, Shahud, can you please confirm if you can see that video?
Yes, but you did not start it yet. Please play the
Yeah.
video. Yes, it's good.
Okay. So like I showed you before, this is a conveyor belt, and then here we have a metal detector. If the feedstock contains any metal pieces, so here will alarm will beam up, and then we can remove it, because if there is a metal, so that may cause the processing problem afterwards. And then this sorry. So this feedstock is going in the densification units that is just is behind. So that transfer this feedstock in the shredded further into microfibers. And then this is extruder. So this feedstock feed the extruder gradually, and then when we have a stable process, so we set a specific feeding rate just from here. And then you have a vacuum system to remove all the humidity from the feedstock. And then here you have a filtration system. In this line, we have a backflash filtration system. So that means that there is like two filters at the same time, two piston type filtration system. That means that you don't have to stop the process. So your melt stream is filtered during the processing. So then if the contamination is so high, so you have to remove the filters depending on the level of contamination. And then at the end, here is that you get the pellets. This is a water collection system. The melt stream is transferred into the pellet. Here is a cutter here. And then this melt stream is transferred into the pellet. So at the end, it's collected by the waters. And then here you have a dryer that removes all the water from the pellets and separate and dry the pellets. And then at the end here you get the pellets out of this material. So here you have a recycle PET, recycled PET pellets. So, but here we have a different challenges during this recycling feedstock. That means that, like I said, if the material requires high filtration, if the feedstock contains a lot of contamination, so you have to remove all the impurities from your feedstock. For the moment, we have a, like I said, dual piston screen changer. This is just for R&D purpose, but if it requires a high filtration, so we have to put a high filtration system. Arima is one of the company that develops. I can show you the video. You can see the YouTube, or
No.
you can see that. No, I think I have to reshare my screen. Just give me a second. Yes, cannot see. You cannot see the screen, right? Just a second. Now you can see my screen, right? You
Yes.
can see my screen, right? YouTube
Yes.
screen, right?
Yeah. Yeah.
So here is the polymer melt with a lot of contamination inside, and this is filtration system. So like I said, if the material feedstock have a lot of high contamination level, so you have to remove the impurities continuously. So this is a laser filter from Arima. Um, that continuously removes the impurities. So here is a feedstock melt stream with all the contamination, and this is a blade that continuously removes all the impurities from the polymer melt stream. So that removes all the contamination from the polymer melt stream, and then from the other side you can have the purified melt stream for to get the purified pellets afterwards. Let me share my second screen. Yeah, now you can see my presentation again, right?
Yes.
Yeah, so if your feedstock contains high contamination, so you may have big challenge during processing. So you may require a high filtration. So in the market, there are a lot different types of filters available. This is the continuous filter that I give an example that may put for the industrial scale filtration system. And then we have a second challenge during the textile recycling. We lose the polymer IV. Polymer IV is related to the polymer molecular weight. So after recycling, the polymer IV decrease. So and then these pellets may be not suitable to develop the fiber out of that. So when I was in the previous slide when I presenting the closed loop recycle, so this is a big challenge here that you must have to have a certain IV in order to process it in the melt spinning to develop the fibers afterwards. So in the for the moment for polyester, for example, there is a possibility you can do is like the process polycondensation process that you can perform on this recycled material to increase their polymer IV and to make them more suitable for the fiber development afterwards. And then you may have the possibility for the there are different processes like give you one example for polycondensation process. And in polycondensation there have two types, solid state and liquid state. So depending on the IV that you require, so you choose the process. And then when you recycle the text and use textile, so that may requires that may have contains different dyes and coatings. For example, you apply the spin finish over the filaments. So if the percentage of these colors and the coatings is so high, that can cause the recycling processing problems. And also if you, for example, if you want to develop a textile, for example, from black feedstock and you want to get a white one, so you cannot get it through the thermomechanical process. So if you put black, you will get black at the end. So we are limited here from the colors, right? Yeah. And then if your feedstock contains a blend of two materials, for these days, like we commonly use a blend of polyester and elastane and polyamide and elastane based material for apparel from the apparel textile. So these two materials, for example, polyester and elastane, they process at different temperature. So if you put in the thermomechanical process, so maybe elastane can burn and become the impurity in your recycle material. So you have to be careful, and you must know the certain percentage of elastane So because we are limited, you cannot process it like high percentage of elastane with polyester fabrics, for example. So you have to be very careful when you process your material in the thermomechanical recycling process. You must know what you are feeding. So that's why I said the sorting of the textile is very important. If you don't sort your material based on their type and the color, so you may have the problems at the end. So this is the filter that I took from the IREMA line, the thermomechanical recycling. So you can see that the filter is like highly contaminated and then can block the process. And then if you don't change the filter continuously, then you cannot recycle this process, this material. So you have to continuously purify the melt stream in order to get the good quality granules afterwards. So at SETI, we have different success for on different materials. For example, polyester-based fabrics, post-consumer and post-production with limited textile dyes, and then we had the success to process the polyester-based fabrics with 2% of elastane. So, and we found that if you have a elastane contact more than 2%, cause polymer processing issues. And then we also during the COVID, there was a big market for recycling the face masks. So we also had the success to recycle the face masks, and then we also recycle the post production polyamide 6 and polyamide 66 base material that is mainly fishing nets. I will show you the photo afterwards. And also we also recycle the bio-based and the elastane-based post-production textile materials. So in SETI, we have different facilities from Heels and Arima and Coperion, including thermomechanical recycling. We have spun-bone lines, and then we have a melt-blown, uh, and then we have a melt spinning multi-component line. So how we work is that we recycle the material, and then the compounding line help us to develop if the polymer IV is not suitable. So coherent line can help us to develop and to get the more suitable IV of the polymers. And then we perform the rheology, and depending on the rheology, we develop the fibers for textile applications. And in fibers, we have different types of fibers that we can develop, from monocomponent to bi and tri-component. So there is a possibility because, like I said, after recycling, we lose the mechanical properties or physical properties of your material. So then there is another challenge, how you get that mechanical strength, because for each application you need a certain mechanical properties. So in thanks to our lines or our scientific approach that help us to develop the fiber with certain mechanical property that can fulfill the customer demands. So this is the fishing net that we recycle through our thermomechanical recycling process, and then we get the fibers from mat spinning process, and then from that filament we got the knitted fabric. So this was the very interesting project to work on. And then we had another project where we recycle the like I give you an example before. So we recycle the polyester based curtains. This is like we said, we shred it, and then we densified it, and then we get the pellets. And from that pellet, we perform the rheological analysis if the material properties is suitable or not for mat spinning to develop the fibers. So here, after this step, when the viscosity or polymer IV is suitable, then we use that granules to develop the textile. So I made another video to show you how the melt spinning works. So this is the you can see the video screen, right? Shahud, can you
Yes.
please confirm? Yeah, okay.
Yeah.
So this is a spin pack, or you can from the melts polymer melts or recycled material is coming from different extruders, and this is a spin pack, and that contains a number of holes, certain number of holes, and then we transfer these granules into a fiber. So So we draw it through the different draw rolls, and this is a filament. And then at the end, you get the continuous filament, and then you can make the knitted textile afterwards. You may notice that after the recycling, because we put the white one, and then you get uh, then because like I said before, after recycling there is polymer material degradation, and because of that it's changed the color. So and then if the color is like, I mean, is very poor, so you cannot make the final product out of this because it looks yellow. So we help our customer to improve the whiteness of the recycled materials. This is just the whiteness. We have also solution for colors. For example, like I give you example before. If we put black, you will get black through the thermomechanical process. But thanks to our scientific approach, we can offer to our customer if they want to have a colorful filament, or if they have for example black feedstock to recycle. So we have the solution to help them to give a different range of colors at the fiber scale or the textile scale. So we help our customers to improve the whiteness and to develop the different color shades. So this was the general overview of the thermomechanical textile recycling process. So like I said, we have the difficulty in the sorting, and the after the processing you lose the polymer IV. So we are working on the sorting and dismantling process, how we can improve it, and how we can improve the polyester IV to make it more suitable for textile application. And also, I give you example of if your feedstock contains a blend, so that may require a chemical recycling process, because through the thermomechanical recycling process you cannot separate. So if it requires, if it's a blend, we have to do the chemical recycling, so you can really separate the two feedstock, and then you can process separately. And then thanks to our Biko yarn development, that help to gain the certain mechanical properties and to satisfy the requirement. Also, I would like to take the opportunity to announce we recently bought the FET line. This is a custom design line from UK. It's a bi-component line. It's more production line, said that you can produce, I think, 50 kg a day. I think so. And this line is a custom design line, and that means that we can have a staple fiber from this line. And also this line contains a radial quenching that you can develop this different shape or different kind of fibers, and then you can really play with the polymer chains and the fiber orientation. If you like to know more about this line, of course, you can contact me. And also there is an article published in Innovative Textile. Here is the link, so feel free to visit it. Thank you very much for listening. If you have question, I would please to answer them. Thank you.
Uh, Thank you very much for giving overview on thermomechanical recycling. And for the audience, if you have some question, you can type in a chat and we will discuss one by one.
So thank you very much, Dr. Kaleem, for excellent presentation. Sorry, I was not there at the start, but it is actually an excellent presentation, and hope so our audience will have some very good questions. I have just to start with, I have a question. A couple of days ago, we were in LCI. Formerly, it was ICI polyester. I think you have heard about ICI. So they were making like 100% recycled polyester fiber from PET bottles. Of course, today our focus was more about fiber to fiber recycling. But there was a problem that they have like some harsher feeling. The fiber was stiffer one. So how we can remove that problem to reduce its stiffness, actually to improve its applicability.
Sophie, I well understand your question. So you are addressing the polyester material from ICI. It's a bottle-based material, right? Recycled from the bottle, right? And we have the difficulty. This material have a more stiffness, right?
Yes.
So stiffness, like if you have a more finer filament, and you can reduce the stiffness of the filament, and then you can play a quenching with the quenching of your process of the filament. So that can if you play with the different cooling rates, you can improve the stiffness of your fibers. So this is the principle. I think you can use it. And also yeah, this is the two different main parameters that you can use to improve the stiffness that you are looking for: the cooling rate and the fineness of the filament. I hope I answer your question.
Okay, thank you very much. In fact, it was not on behalf of LCI. It was like for my own personal understanding. So meanwhile, we have some questions for our audience, Dr. Shaw.
Yes, there is one question. They want to understand what is different between your product and China-based products like recycled synthetic materials.
China is mainly focused on based on the bottle-based recycle materials. They are mainly focused on the bottle-based recycle. So here we can offer both bottle-based recycle fiber or textile-based recycled fiber. But the thing is, the European Union is focusing and banned bottle to fiber recycling. So they force to do the textile to textile recycling. The major reason is textile is causing a uh, causing a big pollution, like bottles, plastic bottle. So the main focus is to offer the textile to textile solution. So the China-based products are mainly focused on the bottle-based recycled fibers.
No, is there any comparison between textile-based recycling? Because he actually want to know difference between textile-based recycling of China and European.
Textile based, that Mm, China. I don't see a big difference. I don't see a big difference. It's based on the post-consumer. If you talk about the post-consumer, so I don't see a big difference in if you talk about the thermomechanical recycling process. I don't see a big difference.
Okay. So
Yeah, it is a
another question is there any data available regarding the properties comparison of virgin material and recycled materials? Like if we have some product developed from the recycled materials, what percentage will be the properties that will be reduced due to this recycling of the material?
So it's based on the raw materials that you are recycling. For example, uh, if you talk about the polyester-based material, if you have to know the virgin material that you use to make that product, and then you have to study after recycling how much there is a loss after recycling. So you have to study. So each material is different. Each material after processing behaves differently. So you have
No,
to
no.
study.
For example, if I have the one polyester based 100% polyester shirt developed from the virgin material, and one I have the 100% polyester based shirt developed from the 100% recycled material. So I cannot compare the properties of these two materials. How I can say okay, if the property is 40% reduced, then it's okay. Something like this.
Because after recycling there is a loss in the mechanical properties. If you
Of
make
course.
a if there is a loss, if there is a big loss, you cannot make a shirt out of this polyester, right? So you have
Hmm.
to make, when you have a certain range of these mechanical properties, then you can make a textile. So you have to at that level, you have to be at that in that range to develop. If there is a big loss, you cannot make a textile
Okay.
out of this. So you have to be in that range as compared to as the virgin material. Of course, if there is
Okay.
a yes, what we are now facing, because every day we face there is a different target mechanical properties that we wanted to achieve. For example, one customer, I give you example of curtains, that it requires more mechanical properties, and one came with the another requirement. So we have the bicomponent fiber or the multi-component fiber can help to improve that properties, the mechanical, and then you can compete the virgin as well. It's comparable with the virgin materials that you
Hmm.
wanted to achieve. If there is a big, you cannot have, because after the when you get the filament, you have to do the post texturization and you have to make a foil yarn out of this. If the strength is not enough, you cannot post processing. So, but we have the scientific approach now. Thanks to the scientific approach, you can develop multi-component fibers, or you can improve the properties of the recycled materials to end that range. So at the end, you have the same level of the mechanical properties. There's no
Okay, so
difference.
next question is how you have improved the whiteness of the recycled materials, like you were talking about the colored, um, if there is some mixing or something in the recycled material.
So we have some additives that we introduce in the recycled materials to improve the whiteness of this recycled material. I cannot disclose too much the name and the it's all about the confidentiality, the process that we use to develop the white. But I can say we use different additives to enhance the whiteness of at the filament level.
Okay, so next question is how to avoid the thermal oxidation degradation.
So oxidation is related to if you have a high moisture content in your feedstock, that can cause the thermal degradation or hydrolysis during the processing. So you must make sure that your feedstock contains a certain humidity level, and then you must ensure during the process you have a good vacuum system. Then you can minimize that hydrolysis or degradation.
Okay, So there is some more questions. Wait a minute. Is like you talked about mechanical recycling. Is there any number of cycles who can recycle the material?
Yeah, so this is a research full can be a full research thesis, PhD thesis. So like I said, every material behave differently. So you have to study how many cycles we can do for processing this type of material. So for the moment, to be honest, we haven't studied the material how many times it can be recycled, because this is the new topics now, the hot topics now for the recycling. So sooner or later we will come to that.
Okay. And the next question is it's little bit away from our topic, but you can just answer it if you want. Is there any enzymatic based recycling?
It is mostly belongs to the chemical recycling, not thermomechanical. So of
Yes.
course, yeah, yes, there are a lot of recycling process that involves enzymatic. For example, if I give you example of if you want to separate two materials like polyester and bio-based, so you or the elastane based, so you use the enzymatic process to separate the two materials together from each other.
Okay. The next question is what blend ratio of the recycled and virgin polyester you suggest? I think it's not about the suggestion, it's about the requirement, but anyway, you can answer it if you want.
Blend ratio, I give you one of the example of polyamide and elastane, or the polyester and elastane. At the moment, we can process this blend if it contains 2% of elastane. If it's more than 2% of elastane, that can cause processing issues. If it's a blend of polyester and polyamide, then you may have a less difficulty, but you can process it. Yeah.
Okay. The next question is about the price. The recycled thermomechanical recycling will be costly then as compared with the virgin materials, like we are adding some process, or what will be the difference between the price? Approximate.
Difference between what, the virgin material and the recycled one?
Like if I have the polyester fibers, virgin polyester fibers, and the second option is the recycled one, what will be the price difference?
Of course, virgin will be like more expensive.
Like
The
for
reason,
example,
like nowadays, the difference, I cannot say this is a much difference, because I'm not the business guy that can tell you this is the price difference. But for the moment, like if you are landfilling your textile waste, and if you and another person is putting in a practice and remaking, reusing that material into textile and transforming this waste textile into fibers, so of course this will be, I think, comparatively cheaper, if you as compared to the virgin based material, where you the cost of the raw materials, the cost of the processing is also involved.
okay. The next question was, is it currently it is being performed on just a lab scale, or it is possible to availability on the industrial level of this recycling? And is there any issue of supply chain?
Um, for the moment, we are doing the pilot scale. The industrial scale is not very common for the moment, because of different issues. Because textile recycling is still in the research and development phase. So if you talk about the thermomechanical processing, so I don't think so if there is a really industrial production of the textile recycling. It will take maybe some years, because I said there is a lack of the awareness and the lack of knowledge about the textile recycling. So It will take
This is
some
the
time.
case of this is the case of thermomechanical or thermochemical and mechanical both.
Thermomechanical and chemical as well. If you talk chemical, if is yeah, both you can consider still a research and development phase. It will take some time to get at the really industrial scale. We are missing here in Europe. In Europe, we are missing the industrial plant of the that can do thermomechanical recycling of the, for example, polyester base.
Okay. And the next question was, what type of textile materials are suitable? I think you already told approximately 2% of lycra is lasting material is possible for the recycling. And the next question is, by adding additives in thermomechanical recycling material, how this process will remain sustainable? Yes, like you told in previous questions, you have some additives to add for the whiteness. So if you have some additives, so then you can claim it is a sustainable process.
It depend on the additive, what kind of additives you are putting. If it's, for example, maybe a bio-based you can use if you want to make your process more sustainable or your product is more sustainable, right? Or you can use that kind of, or any kind of material that is already being recycled. So you can link that product, that this my product is fully sustainable and the recycle, and that supports sustainability.
Okay. So, and the next, we have to finish. We can take 1, 2 questions and then the final words from Dr. Muzammil. Just 1 or 2 questions. What about the polyester cotton blended recycling?
Through thermomechanical recycling process,
Yes.
we cannot process it. The problem in this material is like cotton is cellular based material, is very sensitive to heat. So when you, for example, put in the thermomechanical, for example, polyester, if you process it at 270 degrees centigrade, so the cellulose or the cotton will burn out and will clog your process. So you cannot really process the blend of polyester and cotton-based material. So you have to make sure is like the doesn't contain, because this process is only designed, thermomechanical is mostly designed for the thermoplastic material, not for the thermoset, nor for the natural fibers or natural materials.
Okay, so we have the last question. How do you see the sustainability aspects in terms of energy savings, CO2 emissions that we are adding when we have again processing it for the recycling? Of course, we are consuming the electricity, we are generating CO2 emissions during the process.
So if we really develop a process, minimizing all this effect, at least the recycling process is much better than the product that you develop from the recycle is much better than as compared to the products that you made from the virgin material, right? So at the end, if you have the fully developed the recycle process, you decrease the reliability on the fossil materials, and at the end, the carbon emission will be less, I think, at the end.
Okay, so I think we have to close now. If some question is missed during this discussion, I'm really sorry, but I try to take as much possible. And thank you very much for all of you to be the part of this webinar. And thank you very much for Dr. Muhammad Kaleem to giving us the time. And for the Dr. Muzammal, if you have some final remarks.
So thank you very much, Dr. Kaleem. I have 2 very quick questions for the audience and for you as well. One is about SETI and other one is about, so we have like different kind of technologies available at the moment other than mechanical recycling. One is like thermomechanical recycling is one of them. Then we have chemical polymer recycling and the chemical monomer recycling. In terms of commercialization readiness, which one you think it is the most the nearest technology or available one to adapt or can be used?
I would say thermomechanical, because it's if you talk about mechanical, the chemical recycling polymers or monomers, that takes still in the research and development phase and take more time and involves more complicated process to you can imagine, right? In thermomechanical, you just recycle and process it, and you make a fiber directly. I show you in few minutes how we process it. If I explain you the chemistry, how you recycle the monomers and how you recycle the polymers, you really need a go deeply in chemistry, right? So the readily available, I think, is much quicker will be thermomechanical. That will be in few years. You will see it will be industrialized. You will see that.
My last question is about the role of SETI. If someone want to involve or someone want to get support from SETI, so please share the contact detail of the person who is responsible for your commercialization part so that the people can contact.
From SETI, mainly I'm the responsible of the recycling project. So I'm mainly involved. I'm the key person that was running all the recycling material. You feel free to contact me. So being Pakistani, so I took this opportunity. Thank you. I really appreciate for that you organized this webinar on this topic, because we are really missing in our country the thermomechanical recycling. So being Pakistani, I can play a key role to introduce that technology to help our people or to help our industries to introduce that. And why not we develop that process and to industrialize that process in Pakistan? Why not? Because we are doing somehow for it's rare in China. Yeah. So if we develop in Pakistan, so we really help the circular economy and also the global warming effect that we are facing. So I'm happy. I will be really happy to to transfer my knowledge and my skills to help our industries and to groom our economy. So feel free to contact me. I'm the key person to help you out there.
So thank you very much, Dr. Kaleem. And it is really nice to see you after a very, very long time. And hope so we will have such kind of sessions, especially on recycling. I have seen your facilities, and those are amazing, amazing. And thank you everyone for participating. And we will welcome feedback from your side. If you want to have some seminar on certain topic, we can conduct it. So thank you very much, everyone.
Thank you very much, everyone. Have a nice day. Take care.
Bye.